What are real, imaginary, and complex roots of quadratic equations? Have you ever wondered what happens when you try to solve a quadratic equation? Today, we will break down the concepts of real, imaginary, and complex roots in a way that makes sense. A quadratic equation is a polynomial equation that looks like this: a times x squared plus b times x plus c equals 0. Here, a, b, and c are real numbers, and a cannot be 0. The solutions to this equation are called roots, and they can be real or complex numbers. The key to understanding these roots lies in something called the discriminant, which we calculate as delta equals b squared minus for times a times c. Let's start with real roots. When the discriminant is greater than 0, the quadratic equation has two distinct real roots. This means the graph of the quadratic function crosses the x-axis at 2 points. If the discriminant equals 0, the equation has one real root that is repeated. This is often called a double root, and in this case, the graph just touches the x-axis. Now let's talk about imaginary roots. These roots come into play when the discriminant is less than 0. Since the square root of a negative number is not defined among real numbers, we use the imaginary unit, which we denote as I, where I equals the square root of -1. Imaginary roots cannot be found on the real number line, as they are not real numbers. Next, we have complex roots. Complex roots include imaginary roots but are broader in scope. When the discriminant is less than 0, the roots take the form of a plus by and a minus by, where a and b are real numbers and I is the imaginary unit. These roots always appear in conjugate pairs, meaning they are identical except for the sign between the real and imaginary parts. When graphed, complex roots indicate that the parabola does not intersect the x-axis, lying entirely above or below it. To find these roots, we often use the quadratic formula, which is x equals negative b plus or minus the square root of delta divided by 2 times a if the discriminant is greater than or equal to 0. The square root of delta is a real number, leading to real roots. If the discriminant is less than 0, we find that the square root of delta equals the square root of negative k, which equals I times the square root of k, where k is a positive number. This results in complex conjugate roots. Let's look at a practical example. Consider the quadratic equation squared plus 4 times x plus 5 equals 0. First, we calculate the discriminant, delta equals 4 squared minus 4 times 1 times 5, which gives us 16 minus 20, resulting in -4. Since this is less than 0, we know the roots are complex. Using the quadratic formula, we find equals negative for plus or minus the square root of negative for divided by 2. This simplifies to negative to plus or minus I. Understanding the nature of roots is essential for graphing quadratic functions and solving real-world problems. Imaginary and complex roots expand our number system, allowing solutions to all quadratic equations. This makes algebra more complete and accessible for everyone.